Hi, Sarah. I've got a picture of your assignment question here on the screen, and I'm going to help you get started on it. I think that the big trick to getting started on this one actually is to reposition the two parabolas that you're given, okay? The equations that you're given are y equals a minus x squared over 4. So that's the upside down parabola. And the other one is y equals x squared. And so that's this one, okay? Now, the a minus x over 4 is a minus 1/4 x squared. So it's only the a that affects the position of the vertex. So this value here is going to be a on the y-axis, like the y-intercept is going to be a, 0a, right at this point, okay? So the trick that I think is going to make this a lot easier is if we extend our axis down below and we take the first parabola and we move it down by a units. So that's what it's going to look like. And then the second parabola, we have to take that guy down and move it down by a units also. So it's going to start about here and it's going to go up like it did before, okay? So if you do that, what's going to happen is the equation of the green one, it's going to become y equals x squared minus a. And the equation of the blue one, it's going to become y equals negative x squared over 4. And believe it or not, that actually is going to make it easier for us to find the point of intersection. And we need that so that we can find the integral and find the area between the two curves. So if we start with x squared minus a equals negative x squared over 4, then we have 4x squared plus x squared equals 4a, or 5x squared equals 4a, and then x squared equals 4 over 5a. So x is going to be the square root of that, and when we take the square root, it's a plus or minus, so that gives us the x on either side of the axis, of the y-axis. So that's going to give us the x value here and the x value here where those two curves intersect. So what it gives you basically is your a and your b for your definite integral. So now what we can do is actually find the area between the two curves from positive root 4 over 5a to negative root 4 over 5a, or the other way around if you want to say it like that. And we start with the top curve, which is going to be negative x squared over 4, and we minus the bottom curve, which is negative x squared minus a minus x squared minus a, like that, dx. And so if you simplify that, then you're going to end up with negative 5 over 4 x squared plus a, and that's what you need to integrate and then set equal to 40 over 3 in order to solve for a. But you're going to be substituting, don't forget, these values in for x in your integral. So the only unknown that you'll have is a. So I found it difficult when I worked through this. The integral is not hard at all to take. We can do that quite easily. I found it hard to substitute the square root of 4 over 5a in for x at the end, just because the math was difficult with a whole bunch of rational exponents and stuff. What I did with it is I actually went to Symbolab, www.symbolab.com, and I just put in my equation as a definite integral. I put in these values for my a and my b and put in the equation, and I just asked Symbolab to solve it for me, and it did, and the value that I got did agree with a total area of 40/3, and so I knew that it was correct. So I'm going to let you sort of work with this part of it, see how far you get your integral, try substitute in your a and your b value, and see how close you can get to solving for a. If you need help with it beyond that, then go ahead and email me back. I think it'll just help to break it down into sort of two segments like this so that you can understand what you're doing as you're going along. So that's the first part. I'm going to let you work on that, and then you can contact me. Don't feel like you're bothering me. Please don't apologize for bothering me. This is my job. And just let me know if you need help on sort of the second part where you're actually evaluating your integral, okay? All right.